Let us learn about external and internal linkage in C++. Typically, programs may have thousands, hundreds of thousands, or millions of lines of code. Organizing such a code as a collection of subprograms helps to manage the software project and also to maintain it. These subprograms are called modules, where each module deals with a specific aspect or a cohesive aspect of the data and logic, usually in the form of a class. A module typically contains a header file and implementation files with extensions .h and .cpp. There can be other extensions for these files, but .h and .cpp are commonly used extensions. Header file contains class definitions and function declarations, and implementation file contains variables, objects, and function definitions. The header and implementation file for a module is combined by the preprocessor of the compiler into a translation unit belonging to the same module. In modular programming of this form, linkage is a thing which should get attention and which should be handled properly. It deals with the issues related to allowing or not allowing a translation unit to access a variable or functions defined in other translation unit. First, I will talk about external linkage. Then afterwards, I will also explain internal linkage. If a variable defined in one translation unit is accessible from other translation unit, then we say that the variable has external linkage. Suppose we have two source files, two CPP files, module1.cpp shown on the left side, module2.cpp shown on the right side. These two files can be seen as a very simplistic form of two modules. Module 1 has a global variable x of int type and initialized to 25, and it has a function called compute, receiving double type data, adding it to with x and returning the result. Module 2 has a function sum, receiving int type data, adding it to a variable called result and returning the result. Now suppose module 2 wants to use the variable x defined in module 1, and it asks, hey module 1, I see you have a variable x, is it accessible from other files? If it has external linkage, I would like to use it in my code. Then module 1 replies, yes, x is a global variable with external linkage, so you can access it. Make sure to declare it in your module using keyword extern like this, extern int x. Now module 2 declares variable x as extern using this syntax. This actually confirms external linkage of variable x to module 2. Then module 2 can use this variable x in its computation or in its logic. Now module 2 is happy. Thanks. I have extern declared your variable and I can use it now. With external linkage, you can not only use the variable like the value of x is added to the result variable here, but also you can change the value, which means it is not only read access but also write access, which module 2 gets to the variable x through external linkage. Most of the times a module has a header.s file and implementation.cpp file. In such a case, external declaration can also be placed in the header file, which is included in the translation unit through the header file inclusion or through the preprocessor directive to include the header file module2.h in this case. It is also possible that external declaration can be placed in the header file or .s file belonging to module 1, which can include in the module 2 header file, and which will be eventually included in module 2 translation unit. Now Let us talk a bit about accessing functions across translation units through external linkage. So in this case, module 2 wants to use a function compute, a compute function from module 1 and says, hey module 1, I see you have a function called compute. Do I need to have external linkage declaration for this as well? Module 1 replies, yes, you can use it and you don't need to use external keyword. You just include the declaration of this function before using it as follows. Now module 2 having this declaration included in the header file, module 2 is able to use this function or to call this function in its computation, in its logic. Now we are going to do some coding to demonstrate external linkage. Now I am going to demonstrate external linkage through coding. To demonstrate through coding, I need to have multiple models. At this point I have only main.cpp file. This is one model. I want to create another model, add a new file and call it mod a.cpp. So this is module A, and I want to create another model called mod b.cpp. So we have three models in this case, main, mod A and mod B. In mod A, what I want to do is I want to include a function to compute future value using simple interest. So let me call this function as let's say calculate future value using interest. The thing I want to return here is going to be future value. It could be double type, and I need the information about the initial investment, which is called the present value, or you can call principal value, and then number of years and interest rate. What I'm going to do is I will define interest rate as a variable here in this case, and double equals to 0.404, which means it is 4% interest rate. To use that interest rate, I also need the principal amount and the number of years, so which I'm going to be passing when calling this function as arguments. So principal and then int number of years. So future value is going to be first initialize future value to and you compute you actually add the interest value, and the way you calculate interest value is you just multiply principal with number of years with interest rate, and you finally return future value. So this is the function, and we need to have a return type for this, which is double. So this is the function which receives principal amount and number of years, and it does compute future value by using this interest rate, which is defined here. Now in model B, I actually want to use model B to compute the similar thing, but by using compounding of the interest, or compound interest. So it's instead of a simple interest, it will use compound interest. Let me change simple to compound here. So it is calculate future value using compound interest, and future value is equal to principal. In this case, we actually need to, instead of, we cannot compute like this, we actually need to iterate, use a loop for int I equals to 0, I less than number years, I plus plus, and here principal multiply equals to 1 plus interest rate. So it will actually keep multiplying the principal amount by this expression, which is principal times 1 plus interest rate raised to power number of years. And I think we have to use future value, not principal. So you compute future value and you actually return it. So this is another function, but in this module we don't have access to this interest rate, right? So if I try to compile using this, the compiler will definitely not complain, because this interest rate is not yet accessible, because we are trying to use interest rate which was defined in another model, in model B. So let us try to do compilation of this first and see what error we get before we setting the external linkage. So to do the compilation, I need to switch to the terminal. In the terminal, if I see the files, we have main.cpp, mode.a.cpp, we have 3 files, and the compilation command we have to use in this case is in addition to this main.cpp source file, you also need to add mode.a.cpp. All the source files you need to include here as a list separated by space. And another syntax is same. You have G++ compiler, and then this is for displaying all the warnings, and this is a selection of the compiler, C++ version 11. I have chosen 11 in this case, and this will actually this is the output file, and then these are the source files. So if I compile, it is actually complaining with the interest rate. It is not declared in this scope, right? So you need to do that declaration. Either you can try to have its own variable, let's say double equals to, let's say you want to use another variable with let's say same interest rate. In this case we are going to have an issue, because we have a definition of the same variable and 2 models, and if you combine those 2 models, then it's going to be multiple definition issue. So instead of having this definition, you can actually set an external linkage to the variable which is defined here in this model. So the way of setting external linkage is just to put a keyword extern just before. This is not a definition, this is a declaration, right? With this declaration, it should be okay. If I go to the terminal, try to compile it, right? This is now it is okay. This is complaining undefined reference to interest rate mode b.cpp. Let me go back and check whether that is an issue. I think I need to save this as well, and try to compile one more time. So it's compiling. I didn't have issue, so I'm not executing because I didn't have, the code will not display anything. So now once we have this function here and this interest rate, we have external linkage. We are using that same variable through external linkage in this model. Now I want to have some code that will actually make use of this functions in the main function. In the main function, actually I will be computing the future value, so I need to define present value, which is going to be let me call this uh, present amount equals to 20,000.00, and enter number of years, let me call this 5, and I actually, when I compute the future value, I want to store the computed value in a variable, because the functions that are defined in this models actually do return that value in model A and model B. So let me define those variables, call it future value with compound interest, and future value with simple interest. Now I want to call those functions. Calculate future value using simple interest, pass principal amount and number of years, and the data returned by this value I want to store in future value si. Similarly, I want to call another function for compound interest. It's going to be compound, and finally I want to display this data, compound interest, and so, and if I try to compile, there's going to be one issue. First I want to do compilation and see the issue, explain the issue, and then I will come back and try to fix it. Let me go to the terminal one more time. Compilation, it is complaining, right? So it is complaining in the main function, in main.cpp. It is complaint is that it is not declared, the function was not declared. So a function that was used in the main.cpp is actually not declared. That means what happens is in this program application with multiple models, the compilation of this model, and this model happens independent of each other. So each module has to have the complete information for to compile, and compiler should be able to identify which name, what is the meaning of the name. What, for example, if I use this name, then it should be defined beforehand, or it should be defined or declared, right? For example, in this case, this is something which is declared. This is a declaration, right? Therefore, and we have used this function, but they are not declared in this model. Therefore, you need to include the declaration or prototype of this function before actually using it. So this is a declaration of one function, and compound interest. So this is the declaration of another function. So now I think we should have this should at least compile. I hope it will not complain. Let me see. So it is it has compiled and executed, and now it is displaying the compound interest 24333 and simple interest future value 24000. So compound interest is a little bit I mean, it gives more money. Simple interest is giving less money. Now going back to the code, Usually, I also already told you that this is one module, this is one module, this is one module, right? So usually modules are actually organized in the form of header and .cpp file. So let me do that. So this is the header file for module 1. These two files actually make one module, and also for module B, I want to have header file. So we have these things, and the header file typically include the declaration, but it's important to have some pre-process, header guard, so that the content of this header file is not included for more than one time, because if it is included for multiple times in other modules, that may violate the single one definition rule, and there could be problems. So you need to have you need to guard from including this file multiple times in one translation unit. You can do that by using this this syntax. If not defined, you can give one name. Usually it should be some name that is identifiable through the name of the file itself. So I'm using mod b underscore h define, and then right. So this is the syntax that will actually make sure that this content in this place is not included for more than one time. Now here I'm going to be putting this declaration. In the declaration, it's not necessary to have a name of the parameters, and in this module as well, I want to include a prototype of this function in header file. But before I need, let me have the guard mod a underscore h if not defined. So this is header file, and if you have this header file, then to in the main function, main.cpp, if you are using those functions from those modules, then it's sufficient to have this directive, include directive, to include a.s, and so this will actually prevent you, will actually relieve you from having this declaration of the function that you're going to use. So you can remove this declaration, because this declaration is already will be brought in by this directive. This content will be actually brought in that place, so you don't need to have extra definition there, declaration there. And also in module 1 we have this, module B we have this external declaration, and this it is also more easy and convenient to put this external declaration in the header file of the module where you have defined, like this. This is a header file, because it is defined in the mod a.cpp, and then you include that external statement in the header file, so that you can include this mod a.h in this header file. So this inclusion will automatically bring in that external declaration, and then you will be actually including this .s file in cpp file as well. node b.h. So this inclusion will actually bring in that external declaration into this unit once pre-processing gets completed. Here also you need it's I mean good idea to have a directive to include a.s. Now we have this changes. I hope there's no issue on this. Let me try make sure that I didn't have issue, and then I'll go from there. So in the terminal, there is a problem was not declared in this scope. Let me go back and try to figure out what is happening. Maybe I didn't save this. It's really important. If you are working in this environment, it's really important you save all the files. So back to the terminal. So it is working, right? I didn't have any issue, but only the change from the previous case, previous demonstration is that the code is actually reorganized in the form of header and .cpp file and so on. Now is time to learn internal linkages. Again, we have module 1 and module 2. Module 1 on the left side, module 2 on the right side. Module 1 has a file with .cpp extension containing a global variable x, which is of type int and which is initialized to value 25. It also contains a function called compute, which receives a double typed data, adds it to the global variable x, and returns the result. On the right side, I have a module 2.cpp file containing a function called sum, receiving an int data, adding it to a zero initialized variable called result, and returning the result. Now suppose module 2 wants to have a variable x, and it finds that module 1 also contains a variable with the same name x. Then module 2 does ask, hey module 1, I see you have a variable x. I also want to have a variable with the same name. Can I use your variable in my function? And module 1 replies, oh no, I have variable x, but I don't want you or other modules to access it. I don't want my data to be altered by any other outside code. Let me make sure that it is internally linked to my model. Then module 1 inserts the keyword static in that definition of x. That actually turns this variable as an internally linked. That means x is not accessible from other modules. Having this having inserted a static keyword, and it says okay, now my variable is internally linked. You can have your own variable x, but make sure you also internally link that variable. Now module 2 says okay, then I will define my own variable, internally link, and use it. Now module 2 uses defines its variable x. It is not necessary that you have to have the same type. It could be different type, double type, and it initializes it to some value, and it also ensures that that variable is internally linked by inserting keyword static in the beginning. And here module 2 uses internally linked variable in the function logic. Now here in module 1 and module 2 have their own variables x. They are different variables, they get different memory space, and they are visible to their respective modules only. Now it is time to do some coding, internal linkage coding. If you want to keep a variable or function private to a translation unit, then you can set internal linkage for that variable or function. Now to do coding for internal linkage, let me do some cleaning up of the code that I did previously. I'm going to remove everything here. Remove this thing. Actually, I want to change. I will only demonstrate using .cpp file. I'm not going to be using .header file in this. Delete header file, and I want to be doing I want to have a course A and course B module. So let me change the name to from mode to this is a module for course A, and this is course B. So we have course A, and in the course A what I want to do is I want to actually compute the total marks. For example, the students may have a midterm test and final test. So in midterm test, a student can get certain marks, midterm marks, and final test can get certain marks, and different courses have a different way of combining computing the total marks. For some courses it could be 50% weightage for midterm and final test. Some courses it could be midterm test may final test may get more weightage than midterm test. So for that purpose I want to have a function. It's going to be a very simple function. Total marks, midterm marks, first parameter, and final test marks, second parameter. So it will do let me have a variable to store the total marks, and total marks equals to, you want to give some weightage, midterm marks multiplied by some weightage that is given to midterm size. Midterm, let me call this midterm test weightage plus final test marks times final test weightage. So let me put this in multiple lines. So it is midterm marks multiplied by midterm test weightage, and final test marks, final test weightage. Here midterm test and weightage, we can have a variable to define like the variable like this. It could be I think it would be easy for the user to use if we define weightage in percentage. So let me have 50%, and if it is percentage then you need to divide this. This should be the thing that you place here should be in the fractional form. So if it is 50 then it should be 0.5. So you divide this by 100.0. If you just divide by 100, it is going to be integer division, so there could be loss of information. So make sure that you divide, you carry out the double or floating point division. So I also want to have the weightage for the final test. In this case, midterm in this particular course, midterm test marks gets 50% weightage, and final test marks get 50% weightage, and you return the total marks computed. So this is the function we have, and these are the variables. And in the another module I also want to have the similar function and variables. but in this case the I mean let me just make a correction, because I have not placed return type, so I need to have a return type double here, because this is the type of this variable is double. So and let me do the same change in course B. So this is the function, right? So if I want to make sure that uh, you know, course A has this variable, course B has this variable with the same name. I don't want to use different name for this. I mean, for this weightage for the midterm and weightage for final. In that case, it will be an issue, because we have a multiple definition problem. This variable is defined multiple times in two models, so we want to avoid that. And in fact, as a matter of fact, I actually don't want this variable to be, I mean, I don't want any other models to use this variable. That means I actually want to internally link this uh, these two variables. So I can do so by inserting the keyword called static. So static will ensure that the variable defined variable is only visible, is linked to the current translation unit. And also I want to have other variables in other model. I also want to internally link. Now another problem here is that course A has this function with the same signature as course B. So I also want to, because logic is this total marks logic is this uses this internally linked variables. So I also want to internally link this function as well. I don't want this function to be visible in another model. I can do that by putting a static keyword before this first signature line, and also I can do internally link this function by putting a static keyword here. So now both this variables and this function are internally linked to their corresponding models. And to use, let me make sure that I save this file. And to use this models in main function, I need to I cannot call these functions from the main model. And what I can do is I want to have a function that I can easily access from the main model. So let me have another function called print course A max, which receives midterm max and final term max, and it actually calls that function. It's this is course So if you call from here, this is the only function that is visible. Another function defined in another model is not visible. So this function will be called. That means this weightage values are actually applied. Similarly, I can have a similar function in another model to compute the marks for course B. I mean print marks for course B. So with this we can make use of these functions from the main.cpp file to execute this function, this total marks function in two different models. So here let me put the prototype of this function, and course A max, course B max. So with this, I can in the main function I can create, let's say, a marks array just to test these functions. First marks, the marks for course A would be 88.88 for midterm and 45.44 for final, and for another course it is 55.55 for midterm, 66.66 for final. Now call the function print a marks and pass marks 0 0 and 0 1. So it's going to be these two values passed as arguments in this function invocation. Right, so let us see this code in the execution in the terminal. I think I should have included the name of the in the this was the command that was used in the previous demonstration example mode A, so I should use course A and course B. So this should be course B, and this should be course A. So we have a problem, and the problem is we have used cout, but we have not included IOStream. So let me go back in this file. I've used cout statement, but I didn't have included the library for that, so I need to include IOStream, and also I need to include this library here. Right, let me go back and try again. So another problem is total marks. I think there is some error in type, or maybe this should be uppercase M in course A.cpp and also in course B.cpp. Here and uppercase M. Now the problem is gone. Let me execute. Now it is running without problem. Total marks for course A is 67.16, weighted average of midterm and final. For course B it is 55.55. So again let me explain it. This variable, this name and this function name actually are total internally linked, because we don't want we don't want this variables and function to interfere with the logic of another module, course A, and course A also wants to use the same name and same function. Therefore we actually do internal linking of this functions using this keyword static. And there is another way of doing internal linking, something called let me just write it, anonymous namespace. So a namespace without a name is called anonymous namespace. So here, instead of putting a static keyword, let me put everything in a comment here. There's all these things. Instead of putting a static keyword, I can put everything in the namespace which doesn't have name. So if you have a namespace defined like this, and you would put the name here of, but if you don't put the name, it is called anonymous namespace. So you include everything inside the anonymous namespace, and you actually remove this keyword static. So this will actually make sure that the content of this namespace is only visible in this current model, current translation unit, right? That is I mean, essentially internally linking this variables and the function. You can do the same in another model. In the namespace, and you remove the keyword static. So this will also, I mean, internally link this corresponding variables and total marks to their own model. To the terminal. Yeah, it is working. I don't have any problem here. So this is all I have to talk on internal linkage topic. Thank you for watching this recording.